This is Getty's French Restaurant, a Michelin-starred gourmet institution serving French cuisine at the Peninsula Hotel. It has a great sea view, but only diners that sit by the windows can enjoy a close view of the Victoria Harbour. Moreover, it has live band performances every evening. However, only a minority of diners sitting in the front are in close proximity to the performers on the stage. It is evident that their experiences are restrained by the fixed positions of their seats. Therefore, we have decided to make customers' dining experience a more enjoyable one. This is the rotating restaurant. We have incorporated the live principles of biomimicry and smart materials into our design. Let's take a look at the exterior. There are four glass panels surrounding the restaurant, and the ceiling is composed of ETFE. Let's take a look at the interior. Walking in from the entrance, we can see that the floor of the restaurant is made up of four 250 square feet square pads representing four different zones, namely two food zones, a bar zone, and a stage. The stage zone is a static pad hung to the ceiling by iron rods. Acoustic diffusers are installed on the walls. They amplify and radiate sound energy in many directions evenly, surrounding all customers with orchestral music no matter where they sit. This is the dining zone, where customers enjoy their meals. This is the bar zone, where customers can mingle with their friends and enjoy their company over a glass of wine. Here is how the floor pads move. The three pads swap the positions in a clockwise direction. When they rotate, customers at every table can get a close view of the Victoria Harbour and connect with performers on the stage from a closer distance. Ubiquitous computing is applied to integrate programs and algorithms, allowing the rotating pads to move smoothly without hindering each other. The live principle of evolve to survive is also applied here, as strategies like row paths and speed reduction mechanisms used in traditional models are replicated to achieve uniform and steady motion. This is the ceiling lighting system. Before the start of performances, the stage is dark. During performances, when orchestral players sit on chairs on the stage, their body weights deform the chairs. The piezoelectric materials of the chairs convert this deformation into an electric potential difference, which is then converted into light by electroluminescence, turning on the ceiling lighting system and lightening up the stage. Electricity needed for the lighting system is reduced, and the live principle of being resource efficient is applied here. Let's take a look at the facade. The ceiling is made of ethylene tetrafluoroethylene. The larger pillows result in less structure and foundation, minimizing material usage. In addition, ETFE increases transparency and allows more sunlight to penetrate into the restaurant, so that less energy is needed for lighting and heating systems, minimizing energy consumptions. The live principles of being resource efficient and being locally attuned and responsive are applied here. Now let's take a look at the development process. Firstly, the door and glass panels are added. Secondly, the 1,000 square feet floor is cut into four equal pads of 250 square feet each, with one being the static stage and the other three being movable. Furniture is added into the respective pads. Lastly, the facade is added. That's all for our design. We hope you like it. Thank you.